Okay, great. All right, so for today, we scheduled training on the DMX protocol. As you all know well, DMX is type of protocol used for controlling the lighting within the system, and we of course integrated that part of the control within Control4 home automation using our own DMX gateway, which is the same gateway like you use for the DALI. Just what is different is that internal chip within the gateway is different for the DMX bus. So generally, the product is the same. The eDidio gateway, which we use for the DALI, we also use for the DMX. And also, what would you need, of course, for the DMX, as it is 24-volt system, you would need power adapters and decoders for DMX, which we also provide. If you remember, when I spoke about the DALI, DALI ballasts, DALI drivers, we don't provide ourselves, so you need to rely on the third party. But when we speak about the DMX, we have everything what you need. So gateway, decoders, power adapters, so you do not need to rely on any third party and to think about the compatibility. So I would like firstly to go quickly to Vibrant overview. Vibrant doesn't support just the DMX. We talked about DALI last time. So those are wired protocols which are using the wired control to change lights on the LEDs. But also beside the wired protocols, DMX and DALI, we also have controllers which are connected over Zigbee, where you can connect LED tapes and use Zigbee to wireless connection to have full integration with light control. All of it works on low voltage, 24 volts. That means you do not need a certified electrician to do that part of the installation. And beside these active control components, Vibrant includes all the passive components like LED tapes, extrusions, lens, and everything what would you need for the complete installation. Of course, all products which are available from the Vibrant side, they have their own drivers and they are easily integrated within the Control4, and you have full control, including some additional agents, light specific, like daylight agent is, which is typically used with fully tunable white LEDs. So first of all, to explain what is the difference between LED tapes. We have single channel and multi-channel LED tapes, depending on how many information we need to pass to the LED tape or what we can control on the LED tape itself. So of course, on single channel LED tape, we can control only brightness and maybe through the brightness level also control the temperature of the white. Those are so-called warm dimming LED tapes. But if we would like to have independent control of the brightness, of the white color, of the RGB colors, we need multiple channels. Each channel is in charge for different parameter on the LED tape itself. So based on the number of channels which we need in control of the light, we have two basic dimensions of the LED tape. So single and three channel LEDs, they are 10 millimeter wide, while 4 and 5 channel LED tapes are 12 millimeter wide. So it is important to know when we are specifying the extrusions for it. So based on the type of medium used, is it wired or wireless, and number of channels, we have different ways to control the light. The easiest one are the single channel LEDs, where we can use either Zigbee, using like a standard adaptive phase dimmer for the single channel control, which controls just the brightness, or wired, which is our traditional panelized lighting, where you can control brightness, and in ward dimming LED tapes, you can control through the brightness, temperature of the white as well. When we speak about multi-channel LEDs, we speak about wireless DCM3 and DCM5 controllers. And when we speak about wired, the multi-channel control, we have DMX protocol and the DALI protocol there. So How DMX protocol stands against DALI. So DMX in general is the fastest communication protocol for the light control, which provides the fastest transition of the color on the LED tape. And because of that reason, DMX stands for like a professional lighting equipment, and typically it is used in some commercial implementation concerts, etc., where that fast response and fast transition is critical for the implementation, while DALI is more used in the residential system because that smooth transition from the, for example, from the one temperature of the white to the other. So you can say that DMX is the top protocol for the lighting control. So what is the DMX protocol in fact, and how it works? So let's go from the start. DMX stands for digital multiplexing, and it is in fact RS485 serial protocol with packet-based communication. And each line of DMX can have up to 512 channels. It is like 512 addressable channels which are completely independent on the bus. Each channel can have a byte value which ranges from 0 to 255, which is like 1 byte value. So how loads are connected on the DMX bus? They are practically chained. They are connected physically one after the another, and addresses, those 512 addresses are assigned one after the another. For it is the best practice just to be sure that you don't have any gaps within the setup, and just to know for sure what addresses are free and what addresses are occupied. Besides the limitation per single line of 512 channels, there is limitation in number of devices. So I mentioned that when DMX is in question, we connect our LED tapes to the DMX decoders. So DMX decoder is a device which stands on the DMX bus and which controls the LED tape. So the maximum number of those decoders on the line can be 32, and each decoder can have up to five channels. Just have in mind that this is like theoretical maximum 32, but we always I like to say that you shouldn't go to the maximum. You always use around 80% of that maximum. So you should go on up to, let's say, like around 28, maximum 30 devices, just to be sure you are not hitting the limit. Regarding the wiring, there are also some limitations where wire length is in question. So there is a maximum distance from the gateway itself. That means where the EMX line starts to the last device in the line, and it shouldn't be longer than 300 meters, while distance between each DMX device, which is DMX decoder, shouldn't be longer than 100 meter. So each decoder in the line, it should have input and output, which means there should be line coming in to the decoder and line coming out of the decoder to the next decoder in line. At the end, on the last decoder, on the last device in the chain, there should be a so-called terminator, which is 120 ohm resistor, which is necessary to be plugged in order to be sure that the signal, DMX signal, is not reflecting from the end of the line back and make a noise. So practically the useful signal which goes in one direction, if it is reflecting and going back, it represents noise and can affect reliability of the data transmission on the DMX bus. So this way, here on this picture, you can see the basic elements of the DMX. First of all, we have on the TCP/IP side, we have, for example, Control4 system, some home automation system, which speaks over IP address with DMX gateway. And on DMX gateway, we have start of DMX bus, which is going in daisy chain from one decoder to the another, and it ends with terminator, which is 120 ohm resistor. Okay, so when we are doing the design of the DMX, of course, we first need to know how many LED tapes we have and how many channels we would require. If you remember when we were speaking about the DALI, we needed to know just the number of DALI ballast, the number of DALI drivers, because one address is address of the DALI ballast, and that DALI is in charge for the LED connected to it, regardless of the type of LED. Is it 3-channel, 4-channel, 5-channel LED? It is one address assigned to DALI ballast which controls that LED. With the DMX is a little bit different. With DMX, each channel is like independent parameter. So that means that each decoder doesn't need necessarily to be linked to one LED because we can combine channels as we want. So we have maximum 5 channels per each decoder, but how we will use those channels from the single decoder is up to us. We can use one LED with 5 channels, or two LEDs. Two LEDs with one channel or two channels, or one LED with 3 channels and one LED with 2 channels. We can combine it as we want. Okay, we have something in the chat. Oh, no, no worries, Ronnie. Just feel free to join us. So it is important to remember that each decoder has maximum 5 channels, and those 5 channels are quite flexible. They do not need to be dedicated to the single LED tape. Of course, it is the best practice that one decoder is is connected to a single LED tape, because that provides us the easiest way to follow the setup. That way we know one decoder, one LED tape, and it is easiest for documentation. But that doesn't need to be the case. So when we are speaking about estimation of the channels, we do not speak about the number of independent LED tapes we have. We are speaking of number of channels, and one LED tape can have up to 5 channels. So having limitation of 512 addresses can be easily reached. And because of that, we can use multiple DMX lines and to have bigger pool of DMX channels available. So just remember that 512 addresses, 512 channels doesn't mean 512 loads. That means 512 independent channels, and one LED can use up to 5. So it is not 512 loads, it is less than that. Okay, so when we are addressing our decoder, each channel, to be more precise, each channel has to have different address assigned from 1 to 512. They cannot overlap in terms that we cannot have multiple channels having the same address and to have independent control of them. If multiple channels are having the same address, that means that they are looked like the same device and they are controlled completely the same way. So if we have multiple LEDs which always should act the same way, then in that case we can assign them the same channels. But generally the channels should be different to have independent control of all of them. Okay, so as I mentioned just now, so multiple decoders can have same address, but that means that they simply act like a single load, which means the control of those two loads cannot be independent. What we control on the one load is completely the same control on the other. Um, Limitation of 512 addresses cannot be extended on the single line, so that is like absolute maximum. But if we need more addresses, we can introduce additional DMX line. For example, our gateway have different models. So we have model of gateway, DMX gateway, which support up to 2 DMX line, which means you can have per single gateway with 2 DMX line, you can have 124 channels available from the single gateway. Okay. So let's go quickly through the components in details of each DMX. First of all, we start from the gateway. Uh, it's completely the same principle like with DALI. One side of the gateway is connected to TCP/IP network. It gets IP address. It is identified within the composer, and Control4 using that IP address communicates with the gateway and sends commands to everything what is behind the gateway. On the other side of the gateway, we have serial bus, which is in this case DMX line, and on that line in daisy chain we connect our DMX decoders. Each DMX decoder can have up to 5 channels configured on it. Of course, besides the active components in terms of data communication, we need power adapters, and we also have power adapters on 24 volt for the gateway and for the LED tapes and decoders as well. Everything generally in Vibrant, everything works on 24 volts. So in order to have all devices switched on, we need to have some output from the 24 volts adapter. Okay, so and of course, on the output of the decoder, we connect directly the LED tape, and that is like the end device in the light control. Okay, so how it is connected? First, we have, of course, gateway from which we connect DMX bus to the decoder, and from the decoder we connect LED tape. In this example, we have like a 5 channel LED tape, and each color, for example, in this case, green, red, and blue, and warm white and cool white, they represent single address, single channel. So as you can see here, for a single LED tape, we would need 5 addresses, like it is connected here. Limitation is 512. If we have LED tape with less than 4 channels, we can combine 2 LED tapes on a single DMX decoder, because as I mentioned earlier, all channels on DMX decoder are completely independent, and you can define what each channel is doing. They are just physically on the same box, but how you will connect them, it's up to you, because each channel is addressed separately. So in this case, we have, for example, one RGB tape using the 3 channels, and the other tape is using like full tunable white, cold, and warm white channels. Of course, you can also have like 5 single channel LED tape coming from the single decoder. Just to have in mind that, for example, if I use 5 single channel decoders in my Control4 system, all LED tapes will be like independent light. For the end user, the way how LED tapes are connected to the decoders, it's completely transparent. He's not aware what is connected where. He just sees what lights he has available. Okay. So regarding the addressing, uh, of course, if you would like to have independent control of each of the channels, our channels shouldn't overlap. So how a DMX decoder is configured, we configure first the lowest address of the decoder, the address of the lowest channel. For example, we start from the address 1. Then on the decoder itself, we identify how many channels it has. For example, it has 5 channels. If we add a second decoder after that in daisy chain, we identify it like a channel 6, and we also say, for example, it has 5 channels, etc., etc. So that way, we go all the way up to 512 channels. So what should be configured on the decoder is first the lowest channel address and the number of channels it has. Just have in mind, when you are doing this, you have to do it manually on each of the DMX decoder you have, and you need to take care, you need to take good documentation what addresses are assigned to which decoder to avoid any kind of overlapping. So when we are speaking of the best practices when channel assignment is in question, it is good to simply, whatever number of channels you use on the decoder, to use all decoders with the 5 channels. So for example, I have in this case, 4-channel LED I connected here. I will leave 1 channel available, use all 5 channels here, and start from the 6th channel here. And I will then continue with channel 11, channel 16, channel 21, regardless am I using all 5 channels or not. It is good for 2 reasons. First of all, if you need to change something or you need to add maybe single channel LED, you can easily, without changing whole addressing scheme, you can easily add it to any of the free channels which you have already in your system. And secondly, regarding the documentation regarding of tracing what decoder is on which channel, it's much easier because you know that each decoder starts from address which is increment of 5. So it is 1, 6, 11, 16, 21, etc., etc. So it is easy to trace. What is potential downside of this is that this way you will have a lot of free channels. So you will need definitely more decoders to cover the same number of channels than if you wouldn't leave some channels free. So just have in mind, if you are constrained with the budget, and if it is critical how many decoders you would need there, you would use all the channels. So having channels like 1 to 4, then starting from 5, continuing with the 6 on the second decoder, etc., etc. But that can be quite messy, especially when you need to do some troubleshooting, which LED is connected to which decoder, which address is on which decoder, etc., etc. So I would definitely suggest to always keep the same schedule like this and to leave channels, few channels free on the decoders just for the future, potential future extension or whatever. But generally, you can always create like a compact setup where all channels are utilized one after the another. And you can always, if you are using just 3 channels from the first decoder, you can always set number of channels is 3 and start from channel 4 on the second decoder, etc., etc. Okay, I hope this is clear enough. Is there any questions regarding this?
I
Okay.
just have one
Yes.
stupid question. We speak about 5 channels, but
Yes.
if we use 5 channels to go on 5 different LED trips
Mhm.
and would like to use only the red, it's possible, huh? Or not? Or each
Uh,
channel is assigned to one color
well,
in the module.
you can
It's
configure
just
it
to
as you
understand, huh?
prefer. So on the driver for DMX decoder, you define the number of channels, and you can define what channel is doing what thing. So if you would like just the red, for example, On your RGB tape, you have wire, you have contact, which is just for red. And in that case, you connect just that channel, and you use it as a single channel LED. You have contacts for all the colors, but you connect just the red. And in the decoder, in the driver setup, you say that is like a single channel LED, and it is controlling it like a single channel LED. So each channel is like different light on the user interface.
I know
But
it's stupid. It's just to understand how it works, huh?
yeah. So you do not define what is which color on the decoder, it's on the driver itself or decoder itself. You define it on the contact on the LED. So on the
Yeah,
LED,
okay.
you know which color is going to,
It's right.
or which
Okay.
connection. And if you want to use only red, you use it like a simple single channel LED,
Yeah.
because it is just dimming in that case, right?
Yeah.
It's just defining the brightness. It doesn't need to mix the colors. On the decoder itself, you have marked if you are using multi-channel LED, you have marked what output is dedicated to which channel. So typically you use that pattern. So you have RGB, WW, it is warm white, and CW, which is cold white.
Yeah. Okay.
If you have multiple channel LED. And of course, on the driver, I will show you later in Composer, you have option to say which channel is
Inside to which color?
which. Yes.
Yeah, okay.
And how many channels you use, in fact. Okay, so when decoder is in question, if you remember on the DALI, we didn't need to set up anything on the hardware, on the DALI ballasts. But with DMX, it's completely different. On DMX, from the gateway itself, from the composer, we don't set up the DMX. We set up DMX on decoders, on the hardware directly, on the hard buttons on the decoder. So this is how one of the decoder looks like. I hope you can see it. Okay. So it has like a small display which is telling us what we selected here. It has 4 hard buttons. It has back, enter, up, and down. So with up and down, we are going through the main menu and selecting one of the options. So first option, this A001 is telling us the address, the lowest address and address of the decoder. So that's the first address from where channel addressing is starting on this decoder. So if I would like to change it, I can just go to enter, just to select it, and then with up and down, I can easily change the channel. Do you see that? Do you see how it is changed?
Yes.
Okay. So when I finish, I just go back. So that is the first option which you need manually to set up on each decoder. First, the lowest channel. The second option, when you go to main menu, you go to number of channels, CH. So here you can set up number of channels from 1 to 5. That means how many channels this decoder will use. The same way you click enter and you can go up and down and select 1, 2, 3, 4, or 5 channels to be used. In this case, I'm using 4 channels. And I go back and it saves the setup. Beside those two setups, you have more options to configure, but those two are practically most commonly used. So you have option related, this run 1 should always be selected because that means the decoder is used as a part of home automation system. If I select run 2, that means it is like a standalone. It has some predefined sequence which it is playing through the LED. So I always use run 1 typically. Here I have also decoder type. Then I have gamma curve for brightening to set up, and I have some frequency for PWM as well. Generally, you wouldn't use this is also bit 16 or 8 for the PWM. Generally, what you would use here is just the first channel when you are addressing it and the number of channels used on each decoder. And you have to do it like this. to go to each decoder and manually set first address and how many channels you have. Okay, so as you can see, DALI is much faster to set up. You do not need to do anything manually. Okay, so that is regarding the channel assignment. As you can see on this picture, you have on the right-hand side connections for the channels, and also you have connections for the power supply. You need to bring here a 24 volts power supply, and this plus, it is practically connector for the LED, which provides voltage on the LED tape. I already mentioned in the beginning that all decoders are daisy chained. So you're using DMX bus starting from the gateway, then going from the first decoder to the second, etc., etc. But last decoder, it has to have a 120 ohm resistor, which is called terminator, in order to prevent reflection of the signal. So when EDDO gateway is in question, you have an option with 1 or 2 DMX line, and on each of the line you can have up to 32 decoders and 512 addresses. Also, what we have beside gateway, decoder, and power adapters for DMX, we have so-called splitters. Splitters are allowing that you have your single DMX line split it to multiple branches. So it can provide you up to 4 independent lines coming from the splitter. When you connect the splitter on your DMX line, it allows you to continue your DMX line like it is starting from the splitter. So splitter is like a repeater. So you have additional 32 devices on each of the line, and you have additional like 300 meters on each of the line. So splitter represents the beginning of the DMX line if you put it inside. So even with a single line, you can have longer lengths and you can have more devices there. But just remember, even if you extend the number of devices, you still have the same limitation when number of channel is in question. It is always 512. Splitter cannot provide you more channels available. It just provides you more devices to be connected on the single universe, we call it. That means like on the single line, which is splitted to multiple lines. Why it says here 125 devices? Because if it has 32 devices on each branch, 32 times 4, it is 128. But splitter is counted as a first device on each of the lines. So you can have 31 additional device on each on the branch plus splitter 1, so it is 125 in total, which you can have additionally. Just don't forget, you have more devices, you have more decoders, but still on the one single gateway line, you still are limited with number of 512 channels. So it's always the limitation. So this is a diagram how splitter is connected in the system. So we have a DMX gateway here, and we have a DMX bus going to is entering DMX splitter from the gateway, and from DMX splitter we have like four lines coming out. Each line can go 300 meters length and with 32 devices in total, including splitter, in number of devices. And that is like a single gateway line. So having the splitter on the DMX line, we generally can increase the number of devices, can increase the length of DMX line if we don't have enough, if we simply use more than 32 decoders and need to cover 512 channels with more than 32 decoders in this case. So splitter would allow us to do that. Also, yeah, just to mention, it's obvious, but just to point out, splitter can be used only as a repeater. So if you have two long DMX line, if you're reaching close to 300 meters from the gateway, you can just put a splitter and continue line from there and have additional 300 meters after that. Just have in mind that you have a limited number of splitters there, so you shouldn't have more than uh, 3 splitters in the project. So you cannot go unlimited number of times one splitter after the another. Okay, so regarding the gateway, I already mentioned that we have different models available. It is all gateways are practically the same device, just the chip defining the bus output is different. So we have EDIDIO gateways with single or two bus outputs, and it can be two DALI outputs, it can be two DMX outputs, and it can be combined one output for the DMX and one output for the DALI. So even if you have combined system, you can use single gateway and address both the lines through the single device. Okay, so few examples of the topology. This is the simplest topology of the DMX. We have home automation system. We have a DDO gateway connected to the local network, and we have daisy-chained decoders ending with the terminator on the last decoder. And the second example is with the splitter. So we have the same on the left-hand side is the same thing. We have home automation system coming to the gateway, but from the gateway we are splitting DMX line to two. So on each line we can have up to 32 devices with terminator at the end. Just don't forget that the best practice is to avoid having the number of devices hitting the maximum number. So always design your system to have up to, let's say, 28 devices, 28 decoders on a single DMX line. The third example is so-called mixed control. So if you have multiple systems which can control the DMX, so for example, here is like a manual control of DMX and home automation, we can bring it to device so-called merger, which is defining, so it has output from the EDIDIO gateway, and it has that it's going like a first input, and it has input from the manual control. So it is defining which control will be forwarded to the DMX line. So this way you can have multiple home automation system, to say like that, controlling the same DMX line, and with DMX merger you can define which system is controlling the DMX line. The fourth topology, so practically it is explaining the maximum number of devices. So always the maximum number is 32, and also the maximum length is 300 meters. We shouldn't go above that. For 512 channels is always the limitation per single DMX line. Here we have the distances defined. So as I mentioned in the beginning, DMX line should be below 300 meters, and also there is a limitation with maximum distance between two active components, between two decoders. It shouldn't be longer than 100 meters. Okay, so those are all general guidelines when we speak about design and setup of the DMX decoders, and how we design the number of the channels, how we connect the channels to decoders, etc. DMX bus itself, it has multiple ways how it can be connected, how decoders can be connected between themselves. So you can use like a standard wire and using Phoenix connectors, just connecting wire pairs input output, doing the daisy chain. You can use XLR connectors for specified for the DMX, which are doing the same thing. And also there is a connection like UTP with UTP cable where you can use RJ45 connectors to connect decoders on the DMX bus. So when you take a look on the decoder, I hope you can see this. You have two ports for RJ45 for the UTP cable. You have, that is, one is for input, one is for output. You have also XLR, and of course you have Phoenix connectors, one pair for input and one pair for output. Which one will you use? It's up to you, what is more convenient for you, but generally you use only one of those three. So you just have free of choice to select what's the best for you. Typically, XLR cables, XLR connectors are used in systems where you need often to plug in and plug out to change the system, etc. So you need like a flexible connections which can be easily changed depending on the implementation. Typically, in the residential environment, we would plug it once and we would not change it. So we can typically use Phoenix connector or maybe UTP to make connections between the decoders. Okay, regarding the wire recommendation, it's just important to know that at the end we need to have that terminator which is preventing reflection of the signal in the line. Generally, you can also use the standard, as I mentioned, network cable to have DMX serial bus communication. But don't forget that always the last decoder should have 120 ohm resistor at the end. So regarding the wire recommendation, like any other wire, it is susceptible to interference, to outside noise. So it is always, of course, recommended to use the shielded cable just to be sure that nothing is affecting the transmission of the data on the cable. They should be, of course, twisted pair like UTPs in order to achieve noise cancellation. And practically you should follow the same, regardless of the cable you select, you should always follow the same recommendation when wire length is in question, and that is no more than 100 meters between two devices and no more than 300 meters on a single line without a splitter, of course. Okay, so that is all regarding the wiring of the DMX bus. So generally we have three connectors ready on the decoder: XLR, RJ45 for networking cable, and the standard wiring using the Phoenix connectors. Just maybe what is important to point out, XLR cables, they have to be XLR for DMX, because we have XLR cables for audio as well. But those XLR cables, they have the same connector. You can physically plug it in, but they are inappropriate because they have different impedance, different resistance. So they can burn out the system. So you strictly, if you are using XLR, you have to use DMX XLR cables to prevent any damage of the system. So it's not irrelevant what type of XLR you have, because resistance is different. So it has to be DMX XLR. Okay, so regarding the power supply, there is nothing specific for DMX, what is not for other way of wired LED tapes, like for DALI, etc. So you need, of course, to have a 24-volt adapter, because everything works on 24 volts, including gateway and decoders and splitters as well. You need to calculate what is your required power budget and to use the maximum power budget required, like 80% of the capacity of power adapter you select, just to prevent burnout and just to prevent that you hit the maximum of the power budget you have available from power adapter. But this is nothing specific for DMX. It's like a general lighting design. And regarding the wiring, typical wiring for power supply used is 0.75 to 1 millimeter thickness, and that is all regarding the power supply. So generally, DMX doesn't have anything specific. You just need to take care that you don't have um, too long power wiring to have voltage drop on the wire. So as short as possible would be ideal, and it is good practice if you have, or you better to say it is required, if you have a longer wires, you need to have thicker wires, because thicker wires they have a lower loss of the voltage on the wire length. So longer wire, thicker wire, shorter wire, less thicker wire in that case. Okay, regarding the troubleshooting, as DMX doesn't have the way to scan the line directly from the composer, like we have on the DALI driver, we need to use some devices. We also have, for example, this addict tester we have available on our dealer portal. So if you would like to troubleshoot, is everything working fine on DMX bus? Is there any voltage drop, or is there any noise or anything else? You need directly to plug in within the bus and using this device to measure the signal and to define our old parameters as they should be on the signal, and to practically to isolate what could be the problem. But generally, you would need this addict tool in order to connect directly to the bus and listen what's going on the bus itself. Also, there are some testing options on the gateway itself. So you can start the testing procedure from the gateway, selecting the line of the DMX if you have two DMX line, and starting the minimum and maximum DMX test. And this way it will test all the channels from the minimal to the maximum value, so you can see is there any potential problem with certain decoder, with certain LED connected to that decoder. You check that way that all channels are receiving signal properly and controlling the light connected on that channels in proper way. Okay, so regarding the wiring, those are some, in short, some best guidelines. We do not use any like a wire split on the DMX line. You can use splitter, but you shouldn't split the line without the splitter. It should everything should be daisy chained. That is difference comparing to DALI. On DALI, you can easily do the T splits, etc. On DMX, you shouldn't do it. Uh, the uh, the wires shouldn't be too long between two active components, between two decoders. You shouldn't have more than 100 meters. The best, when you are making connectors between the wires on the DMX line, the best is of course to use predefined connectors. If you cannot do it, the best is to solder them. All wires, practically DMX protocol is in fact RS485 protocol. So wiring used for DMX bus should be rated for RS485 serial protocol. Also, it is typically stranded wires are used. Shielding because of the interference is required just to have reliable transmission. RJ45 connectors typically for permanent wiring. You shouldn't use RJ45 and networking cables for DMX bus if you plan often to plug it in and out. In that case, you should use XLR connectors. Termination is mandatory, so always on the last decoder in the line, put the terminator to prevent signal reflection. And connect commons together but isolate from the ground. That's not the same thing. So just take care when this is in question. Okay. So generally, the main purpose of the best design of the DMX, the main purpose of the wire planning is to separate low voltage wiring from high voltage wiring to prevent any kind of interference. So we have here one example. This is like a real case example, how DMX was wired on one project. So as you can see here, everything is tightened up in a small cabinet, including the power adapters, which have input from the high voltage, including the DMX bus, connection to the LED tapes, DMX gateway, and everything on a really small area. And what was the problem identified when this system is tested is that first flickering was noticeable even on 100% brightness. And there was flickering also on some on tunable white on some temperature. And first of all, what had to be solved here is the hardware placement, how the placement of decoders and power adapters and gateway is organized. So first of all, what was the reason of flickering? It was voltage drop. Because the wire distance was too high, so the voltage on the LED was below 21.6 volts, and that can be easily resolved by using the thicker wire, because thicker wire has a less voltage drop. The second problem, flickering, it was related to the close proximity of the high voltage and low voltage wiring, and also there were no resistor at the end of the DMX cable, and everything is checked like UTP cable, how tight everything is in the single cabinet, and proximity of high voltage and low voltage. So what is done here is practically DMX gateway and recommendable decoders are put away from this cabinet, just to be away from the high voltage cabling. And that way the interference and the noise coming from that is decreased significantly. So you shouldn't definitely by any cost try to optimize your space. Simply the device needs some distance between different parts of the system in order to operate correctly. Okay, so just to show you quickly how it looks like in Composer. If you remember, I was using the same eDidio gateway driver for the DALI. But when I was using DALI, I went to DALI addressing, click new line, and everything was configured manually. When DMX is in question, unfortunately, I don't have that kind of tool. So only what I need to do with DMX is to the same way identify my eDidio gateway by the IP address. So just by SEDP, drag and drop, put it here. When it is linked, first what I need to check is that eDidio gateway is online. When it is online, I can just verify it received the proper address and everything. And I have trigger, I can trigger detect lines just to test lines connected, they are up and running. And when DMX is in question, everything what I explained regarding DMX addressing, it has to be done manually on each of the decoders one by one, assigning the address, first address, the number of channels used, etc., etc. And here I have just option to when all channels are configured, when line is detected, to test individual channels from here and to see is a proper channel responding to tests from the composer. So generally, all setup has to be done manually one by one. We don't have that automized setup directly pushing from the DDO gateway. And that is all what you have from the composer as composer and from the gateway when DMX is in question. Regarding the driver, when I add DMX Lite driver, I define what type of LED is practically on the driver. I have these options to select one of the LED tapes. Is it just a single color or dimming only? Is it fully tunable white, RGB tunable white, RGB, or outdoor RGB? Whatever color, whatever LED I select, I will get different number of channels. So for example, RGB white, when I select, I will get 4 channels available. And here I can see, I can define what channel is controlling which color. And I can define what is the percentage of the white in the color. If I put it 0, that means white wouldn't be used at all. If I put like, I think the 1 is the maximum here. Just to try. Sure, what is maybe 9.9 or 10 is not accepted. So I can put here white mixing ratio higher the number here. That means the white color is more present in the total number mixing. So if it is 0, typically it is some low value like 0.5. Regarding the different LED tapes, so I can use, if I have, for example, single channel LED, I can say the single color, and I will have only one channel to configure here. I can put this channel to be whatever, for example, channel 6. This channel can be on whatever decoder. It will be on the decoder where I define the channel 6. And if I use some other LED, for example, on channel 7, it can be on the same decoder, just different channel numbers. So that means I'm individually controlling each of the LED, but they are connected to the same decoder, because control is not on the decoder level, it is on channel level. So this way you have really flexibility to connect your LEDs as you prefer. Oscar, yes.
Do you know if there's a possibility to add the auto setup mode for DMX in the Edidio? Because for the
You mean
DALI,
like for
it's
DALI? No,
yeah,
you
like
don't have.
okay, because
No,
it's super
so
useful
yes,
for DALI to just
because
add everything with one click.
because of that, we always recommend DALI, because DALI is super fast. With DALI, you don't have any kind of tool, or you do not need any kind of direct interaction with DALI itself. You finish everything from the composer. With the DMX, you need to connect to each decoder independently and to set it up manually. There is no auto config. No.
Okay.
So generally, yeah, just what is important to know, don't be confused about the decoder concept. Decoder is a hardware unit, but channels are independent parameters there. And you are defining driver based on the channels, not based on the decoders. The Control4 doesn't see decoder. For Control4, each channel is independent, regardless is first channel maybe of decoder 1 or second channel decoder 2, regardless to that. So you can organize your channel as you want, regardless on the specific decoders. Just have in mind, of course, that when you select the first channel on the decoder, other additional channels, they need to go in rows. For example, first decoder starts from channel 5. and I have 3 channels, that means 5, 6, and 7 channels are on one decoder. Then I start on the second decoder with channel 8, then I have 5, 8, 9, 10, 11, 12 are on the second, etc., etc. But how I use those channels in Control4 is just up to me, so I can pair them to control any LED here. I can define whatever channel here to control certain color on the driver. As you can see, nowhere in Composer I say which decoder it is. I see only channel, nothing else. Okay, so I think that regarding the DMX, the hardest part, in fact, is just to take care that you do wiring properly, that you don't have any interference, any bad connectors, you don't miss the terminator at the end, resistor, and that you take care just that you don't have too thin wires for longer length or things like that, and too close high voltage, low voltage. They definitely, the worst case is they are just next to each other. It's always better if they have to go near each other. The best is just they have like this cross section. The area, the common area is the smallest. So if they need to cross each other, they need to go like this, not by like this, definitely. So that's the worst case. So if wiring is done good, you have reliable transmission on the serial bus, your DMX would work perfectly. And as I mentioned in the beginning, DMX is in fact used for the more commercial, professional lighting because it provides the fastest transitions, the fastest response to the commands sent from the outside, from the controller. Okay, so this concludes DMX explanation. As you saw, and you, Oscar, asked last time how DMX is configured from a DDO gateway. In fact, you do not configure DMX from a DDO gateway. You do everything like manually on the decoders. Only what you need to do on the DDO gateway is to identify the line and identify the IP address, and that is all. And of course, you have this option for testing the channels directly from the DDO. So this way you can verify that really, for example, channel 3 is the channel I expect to be in the project. So just by changing the value, you can see which channel is which on the system. But everything is done manually. You don't have any kind of auto config or any wizard like you have on DALI. Okay, any question regarding to DMX or Vibrant in general?
Very well explained. Thank you.
Okay,
Yeah.
no worries.
The only question I have is on the screen we have in front of us. We decide the first channel, and then you refresh if you add some new.
You have each channel independently, so you can change the
Yeah, sure,
or
but
channel 7 or.
How do you decide to display a channel?
So just refresh and it will show all channels detected on the bus. Yeah.
Okay.
You don't have you can look it like that. From Composer, you don't have any control of DMX when configuration is in question.
Yeah.
You just read the status, and that's all. You cannot change addressing.
Yeah. So if
Nothing.
I add some decoder, I just have to refresh the bus and
and it should return the channels. Yeah. It is just listening the bus and showing you the channels.
Yeah. Okay.
You do not manually add the channels.
Yeah.
Yeah.
No, all clear.
Okay. Perfect.
Yeah.
Anything else?
Just to double check, the Access DCM5, you cannot use it with the DALI or DMX. It's independent.
Yes.
Okay.
Yeah. So when you mentioned the DCM5, we spoke about, now we covered DALI setup with Vibrant, DMX setup with Vibrant, and I can suggest maybe for the next session, for next week, we can speak about Zigbee on Vibrant. That is DCM5, for example. So we can have one training just to cover that part. And when we cover Zigbee over Vibrant, we practically covered whole Vibrant setup that way.
I find this product is interesting. You can
Well,
control the lights with Zigbee.
I always say, if you are starting with lighting, if you are not familiar with all DMX, DALI, wiring, etc., start with Zigbee, because Zigbee is something what is the easiest to install, what is the easiest to control, and integration is also straightforward. Because everything, all communication between Control4 and LED tape is in fact wireless. Just of course, wireless introduce its own challenges regarding the coverage, obstacles, interference, etc. But when installation is in question, it's uncomparable how easy it is to use Zigbee comparing to wired solutions.
I also see that it has a RF485.
So it has?
I'm seeing
okay.
like another on the picture.
Yeah, but it's not used. It simply, we do not use serial communication with DCM5, just Zigbee.
Okay.
Yeah, perfect.
Okay, so just to check for next week, then are you available maybe Wednesday to schedule next training? Morning, like 10 o'clock again, or maybe 10, 11.
Can we do it 11 maybe? Because we usually have team meetings on Wednesdays, and sometimes they take longer.
We can even do it at 12 if it is more convenient for you. 11 or 12.
I think 11 is fine.
11. Okay, no worries. I will schedule that. I will schedule then for next week training on Vibrant over Zigbee, and we can cover all controllers we have available on Zigbee for the Vibrant, and also I will speak a little bit about the Zigbee protocol and a little bit about best design regarding the wireless communication, things like that. Okay. Okay, perfect. So if that is all, I would like to thank you on your attendance today, and see you